Hey there, class. Mr. Pusky here. Hope you're having a good day so far. Today we're continuing with Chapter 4, which is graphing linear equations and intercepts and stuff like that. Linear equations and functions. So we'll be working with coordinate planes. We'll be working with slope and slope-intercept form, y equals mx plus b, that kind of stuff that you have learned a while ago and probably are really excited to get back into because I know I am. So today's section is 4.1. The name of the lesson is Coordinates and Scatter Plots. Our essential question is, what is the coordinate plane? What are the quadrants of the coordinate plane? And how do we graph points in the coordinate plane? So we have a warm-up, and it says match the following points with their coordinates. Why don't you go ahead and pause the video and see if you can give this a try. All right, so 4, -1. So 4, -1, we're going to go right 4, because it's positive 4, and down 1. Which means it's going to be E. E is right 4 and down 1, which we'll talk about more in the actual lesson here, but just to see if you remember this. 0, 0 is the, what's called the origin, which is right in the middle. It means don't go left or right at all, don't go up or down at all, which means it's going to be D for that problem. -7, 0. So this one's a little tricky. It's going to be either A or C. So -7, 0, does that mean go left 7 and stay on the x-axis, or does it mean go down 7 and stay on the y-axis? Well, the first number tells you to go left or right. The second number tells you to go up or down. So which one's it going to be? For -7, is that left 7 or down 7? That is left 7, so our answer is actually going to be A. So if you can remember that the first number is always left or right, and the second number is always up or down. That will keep things really nice and organized for you. So, for example, down here we have left or right 0 and down 7. So C is actually going to be 0, -7. Okay? If you mix those up, that's okay. It's a very common thing, but just keep in mind the first number is left or right. The second number is up or down. All right, -3, 2. That's going to be left 3 and up 2. So we go left 3, we go up 2. That's going to be B. And the last one is 3, 7. We're going to go right 3. Positive 3 is for your x value is right 3. Up 7 is going to be F. And there is what you should have gotten. If you got all those, good job. Way to go. This is a review from middle school math, so hopefully it's not too challenging, but it is so tricky for a lot of people, so it's a good thing we're going through this stuff here. All right, let's get into it. The vertical axis, is that called the x-axis or the y-axis? It is the y-axis is the vertical axis, which means the horizontal axis is going to be the x-axis. And the origin, like we talked about, is 0, 0. Okay? All right, the quadrants. We have 4 quadrants, and we use Roman numerals when we do this. If you write like regular numbers, 1, 2, 3, 4, that is not technically right. It's not how we use quadrants in math, so make sure you're using the correct notation. So 1 is like an I, 2 is a double I, 3 is like a triple I, and then 4 is actually going to be IV. And the way that works is with V is 5. V is 5, so one line before 5, before the V like this, means it's 4, and then if you do lines after the V, that's going to be like, this is like 5 minus 1, this is like 5 plus 2, which is going to be 7, okay? All right, same thing with like 10, 10 is an X, 10 is an X, and then if you put a 1 before the X, that's going to be 9. If you put 1 after the 10, that's going to be, or 2F, that's going to be 12. At least I think so. I got to review that actually, but pretty sure that's how it's worked. But all we need to know is 1, first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay? So the way the quadrants work is the one that's all positive in both directions is going to be our starting point, which is going to be up in the upper right. And then we're going to go in order. We're either going to go clockwise or counterclockwise. What do you guys think? Clockwise or counterclockwise? You had a 50-50 chance, and we're actually going to go counterclockwise. We're going to go left rather than down. So the second quadrant is going to be over here. The third quadrant is going to be down here. And then we're going to have the fourth quadrant is going to be down in the lower right. So we go around like this. Okay? All right. So what is an ordered pair? An ordered pair, it is a point. It is a what? It is a point in the coordinate plane. And is it going to be x, y, or y, x? You guys remember what that is? It's an x value and a y value. It's going to be like this. All right? It is important to always start at the origin when you're graphing points. You always start at 0, 0, and then you go from there. All right? So, let me turn my page over, actually. So, the x-coordinate tells you to move which direction? Which direction does the x-coordinate tell you to move? If you said left and right, you are correct. It's going to tell you to move left and right. Okay? If x is negative, does that mean move left or right? What do you guys think? It's left. It's left because in the number line, when you're going negative, it's going to be going to the left, right? Negative numbers are to the left. Positive is going to be to the right. Okay? And if x is 0, you're actually going to stay on the y-axis. You're not going to move left or right at all. So if x-coordinate is left or right, that means the y-coordinate is going to be what? It's going to be up and down. Okay? If y is negative, does that mean move down or up? It means move down because negative numbers are down on the coordinate plane, and positive numbers we're going to move up. Okay? And if y is 0, you're going to stay on the x-axis. All right. See if you can go ahead and try numbers 1 through 4, graph all those points and label them, and see if you will check our answers in a second. All right, sounds good. We have J, which is 3, 4. They are both positive. Positive 3 on the x-axis. Is that left 3 or right 3? It is right 3. And then is it up 4 or down 4 if it's positive 4? It's going to be up 4. So our point is going to be right 3 up, 1, 2, 3, 4 right here. This is our J. Okay, 0, negative 2. Now this is tricky. It's either going to be left 2 or down 2. Which one is it going to be? Well, the first number is 0, which means do not go left or right at all. And the second number is down 2. We're actually going to go down 2 and put a point here, okay? So like I said, the first number, that's our K. The first number is left or right. So if it's 0, negative 2, it means don't go left or right at all. It means go down 2. If we had negative 2, 0, that would be left 2 and then stay on the x-axis. Okay? All right, what about L? Negative 4, negative 1. Negative 4, is that left 4 or right 4? That's 1, 2, 3, left 4, and then negative 1. Is that up 1 or down 1? That is down 1. So there's our L. And then we have M. M is negative 8, 0. Is that left 8 or right 8? That is left 8. 1, 2, 3, 4, 5, 6, 7, 8. And then up or down 0, so we're going to stay on the x-axis. That's our M. So your graph should look something like this. All right, now we're going the opposite direction. See if you can do this. It says write the ordered pair that corresponds to the given point. See if you can write the coordinates for each of the points here. Go ahead and give that a try. See how you do. All right, so for A, it looks like we go left 4 and up 2. So left 4, is that positive 4 or negative 4? That's negative 4. And then up 2, is that positive 2 or negative 2? It's positive 2. All right, then we have B. B, it looks like we go from the origin, we go left 2 and then down 4. So left 2, down 4. Left 2, is that positive 2 or negative 2? It's negative 2. And then down 4, is that positive 4 or negative 4? It's negative 4. All right, then C, starting at the origin again, we go left 3 and then we stay on the x-axis. So left 3, is that positive 3 or negative 3? It's negative 3. And then is it up or down at all? It's not. It's going to be 0. It's on the x-axis. It doesn't go up or down at all, it stays. Then we have D. It looks like for D we go right 2 and then we go down 3. So right 2, is that positive 2 or negative 2? It's positive 2. And then down 3, is that positive 3 or negative 3? It's negative 3. All right. Okay, and then we're going the exact, now we're taking those same points and we're going to classify them based on which quadrant or axis they correspond to. So A is right over here. Which quadrant? Remember, quadrant was 1, 2, 3, and then 4. Which quadrant is A in? A is in quadrant 2. See if you can figure out the rest on your own. See how you do. All right, for B, it looks like it's in the lower left, which is going to be quadrant 3. I guess I kind of gave it away when I wrote out those problems there. I probably should get rid of these. But, oh well, no worries. What about C? C is right on which axis? C is on the x-axis, okay? Don't put like 2 and 3. It's not quadrants 2 and 3. It's the x-axis if it's right in between quadrants, okay? That's very important. People usually goof that up, and it's a common mistake. So it's either on a quadrant or it's on an axis. It's not going to be between 1 and 2 or anything like that. Okay. And then D is what quadrant? That is quadrant 4. Okay, last type of example for today, scatter plot. It's a set of data points used to analyze the relationship between two quantities. All right, it says the temperature was taken at a 2-hour interval. Draw the scatter plot for the data. All right, so we have 2 p.m. is 71 degrees, 4 p.m. is 74, 6 p.m. 68, 8 p.m. 63, and 10 p.m. 60 degrees. So, do you think time or temperature is going to go on the x-axis, which is our independent variable? Does time affect temperature, or does the temperature affect what time it is? Time affects what temperature it is, right? So we're going to put time is going to go on the x-axis. Time isn't changed by what temperature it is outside. That'd be kind of crazy. Then we're going to have temperature over here. Okay, now we got to figure out an appropriate scale and stuff here, okay? So what I like to do with the first data point, that's where we start. I'm going to put that at 0, 0. That's going to be kind of our starting point. And I'm going to go up by every 2 boxes. I'm going to put another hour. You can see if you can figure this out on your own. I'm just going through this together really quickly here, but see if you can figure out your own scale and stuff and see if it matches up to what I do. Okay, now this is kind of tricky because we have 71 degrees, we have 60 degrees as our lowest. You want it for your scale, for the temperature, you want to find the lowest and the highest degrees and kind of go a little bit above or below that, usually. So our highest degrees is 74, our lowest is 60, so we're probably going to go from like 60 to 75 is probably what I would do. But another thing we need to do with the graphs is if we don't start at 0 on the y-axis, we need to draw this little kind of diagonal line, I guess, to kind of show that there's data points below that. There's numbers below that we're not including. So I'm going to start at 60. This means we can start at 60 when we draw that little. I can't think of the right word right now, but it's like we're crossing off all the stuff below 60. And then every 2 boxes, I'm going to go up by 5. So that way I can get to. We're going to go 65. We're going to go to 70, then 75. And then we have between 60 and 75 is going to cover all the data points there that we have. All right, so for 2 p.m. we have 71 degrees. So 71 degrees is going to be, so right here in the middle is exactly 72.5. So 71 is going to be a little bit above 70. See if you can graph the rest on your own. See how you do. All right, 4 p.m. is 74. That's going to be a little bit below 75. We have 6 p.m. is 68, a little bit above 60. This is 67.5 right in the middle here, so a little bit above that. 8 o'clock is 63 degrees, which is a little bit above 62.5. And then we have 10 p.m., which is going to be 60 degrees, which is right here. Now, here's a question for you. We followed what the problem told us we were supposed to do, right? My question for you is, does it make sense to connect the dots? Okay? And so take a minute, see if you think yes or no really quick. So I would say yes for this one. It would make sense to connect, and we're not going to, but it would make sense. Because temperature, it doesn't just go from 70 to 74 and then down to 68. It doesn't jump like this, right? There's actually like a gradient. It takes its time going up and down. It doesn't just jump arbitrarily or like without any reason, just like up and down with no reason. It doesn't just go boom and then boom and then boom and then boom like this down here, right? Shoot, I messed up. Give me a sec. 63 is right here and 60 is right here. So for this case, it would make sense to connect the dots. But if we had something like we're measuring number of cars manufactured in between a certain number of years, it would not make sense to connect those because you don't make like partial cars. Like when you connect the line here, that means that every number in between 2 and 4 p.m. or whatever, or every number between 70 and 75, including like 72.1 and 73.6. Like what's 0.6 of a car? Is it possible to get 0.6 of a car? It is not. So you want to be careful and think this through a little bit. if you have temperature or something like that that can actually change gradually, and it makes sense to like connect the dots, you probably would. Let's just connect the dots. Why not? Let's do that. It makes sense. So it is a scatter. It's not really a scatter plot anymore, but we're connecting the dots. But just keep that in mind. It's something to think about. If you are working with certain type of data, it does not make sense to connect the dots, and sometimes it does. With temperature, it does because it changes gradually. It doesn't just jump from 71 to 74 with no in-between. So thank you guys for watching. Have a great day. We will talk soon.